So this is the NH paper widget, and this is one of our early widgets, where widget is a Holochain app which also supports Neighborhoods modular reputation architecture, which is still being fleshed out. So widget is kind of a nascent concept, but it's sort of a subset of Holochain apps which are Neighborhoods compliant. And so this is like an early rough, right? It's somewhat rough, as you'll see, and the UI is not as beautiful as it eventually will be. But the idea here is a sort of social tool for reading and annotating papers. And we had this idea when we're thinking about MetaGov and what MetaGov people might be into reading papers is our best guess. And so, yeah, so basically I will just do some, and as additional context, like the window on the left is connected to one Holochain conductor, which is Holochain's like node, I guess you could say. And the window on the right is a separate conductor, and the two conductors are both running on my machine and talking to each other. So you'll see that updates on one side appear on the other, and vice versa. So I will do some initialization stuff. Please ignore, and then upload a paper. And it will appear. And so say, okay, I'm reading this paper about microgrids, and they made a typo. They said cow. They should have said chicken. So now I've created this annotation, and we'll see it's a little cluttery UI, but the main thing to look at is this state unreviewed. And I can submit an action which moves us into the accepted state. And basically this is a very simple two-state machine where there's unreviewed and accepted, and you can move from one to the other and then vice versa. So this is annotations on papers can move through this simple state machine. Basically, yeah, they can go in unreviewed, get accepted, and then get demoted. And this is, maybe interesting. Maybe it's part of your group's culture of annotating things. You only really want a simple notion of like, is it new? Has somebody looked at it and said it's good? And what, I guess, yeah, okay. I will now show a more complex state machine, which has 4 states. And so this box here is, don't look too hard at it, but this is this language that I built, and it's very verbose because I've not added the language features to make it non-verbose, but this is basically, there's an interpreter for this language, and because we have an interpreter inside of the HAP code, basically, we can update the computations in the state machine functionality on the fly instead of, for example, having to redeploy the app and the whole network of apps, which is much harder in a distributed context because you'd have to get everyone to update kind of in sync. So here we can, basically this text that I just pasted in and submitted is program text, and as soon as it propagates around the network, everyone has moved to a new rules of the game instead of having to update software. So right. And I'm also, oh, sorry, I have to fix some weird JavaScript. Uh, I got the wrong quotation marks in my thing and it'll mess the demo up. So sorry, 1 second. Um, okay, so we now have 4 states and I am mapping what they are. So we now have unreviewed, rejected, tentatively accepted, and fully accepted. Um, these are just kind of arbitrary choices I made. The point is that you can change, oh, and I can show over on the right that things are indeed gossiping around. Okay, so now we've updated the state machine and now you're in the one state. This means rejected. We can go back to unreviewed. We can go over to tentatively accepted. We can go, oh wait, up. We can go to fully accepted. We can go back down to unreviewed. So hopefully that makes some sense. I'm moving kind of fast, and but the point is to show that the rules of the game on annotations can be updated live without having to redeploy the code because we're sort of, yeah, we're kind of cheating by having an interpreter which can dynamically interpret new rules. So, and these are kind of simple examples, like with just the state here is just an integer, basically. It's, yeah, either 0 or 1 or 2 or 3. We can also do, like, this is basically a full programming language in that, like, it's Turing complete. It's just very limited right now. So we could, but since it's Turing complete, we can do richer stuff. So we could have a richer state like this, and again, it will be painful to try to read, but basically we're operating over now a tuple of integers. I haven't added like more complex types, but that's coming. So we start out in the state 0, 0. The first integer is a tag and the second is a count. And so let me update the last. Yeah, so we can now have counts of things, whereas before we didn't have counts. We only had like a single integer state. So now looking down here, the state of this new annotation is unreviewed and count is v in 0. That just means it's a integer in the language. And so for unreviewed, it doesn't, the notion of count doesn't exist really, or it's not meaningful. But if we submit a 1, we'll move into the voting state. And now the count tells us how many up or down votes we have. And 1 is an upvote, 2 is a downvote, just for demo purposes. So I can upvote this and downvote this. And if it goes below the threshold of 5, which we will do right now, now we're in the rejected state. So just showing, and the count got reset. We could also make a new annotation and upvote it off the top to get into accepted. should have made it a lower threshold. Okay, so accepted. Yeah, we got to accepted. And so so this is just showing a like slightly richer state where you can have a count and you can do things conditional on the count exceeding some bound or whatever. Basically just kind of standard integer inequality comparison stuff. So yeah, that's I guess this is kind of a very specific example of this whole demo shows a very specific notion of like metrics or computations that a group could hold, like for their group context, and it is a bit of a like stretch, or it's a ways off from the higher level notions of reputation that Emmeline was talking about, but like these very specific low level detailed notions, and even like beyond this, what I'm showing here, we could imagine relatively easily, I think, building like how many, your standing in the paper widget reading group could be based on how many annotations you have that got accepted minus how many got rejected, and then some other, adding in other relevant details. And all of those could be kind of, say, like your standing in the group could similarly be a dynamically updatable computation, which is held by the group and can be updated live, similar to how the annotation state machine rules can be updated live. And I haven't yet built something to showcase that, but it's like similar in principle. So yeah, I think that's kind of that's like the meat of the demo, showcasing that dynamic ability. And then I guess one other note maybe that here, all the conductors, all the nodes participating are bound by the same like rules. Basically, whatever this state machine computation is on annotations and whatever the starting value is and what the states are labeled, there's consensus on that. Everyone has the same rules on annotations. But like the process of updating that is totally anarchic, or anyone can update at any time, and anyone can update at any time. So this is not how you'd want to do some actually mature group process, because it's a bit too chaotic, I think. But we could imagine needing, like, in order to suggest a new state machine computation, you need a certain threshold of credibility, and maybe something like hinting towards Stack Overflow, if people are familiar with their very ornate system of, I forget what they call it, like rep or something. You need a certain amount of reputation points to be able to like downvote things or cause trouble, and they kind of meter out the ability to do things based on members demonstrating that they deserve this like extra power. So we could imagine, and a thing that gets me excited about this is the ability to update the rules as you're going, and in a cheaper way than synchronized distributed software updates. It would be moving more at the speed of data and people sending around different computations and agreeing on them, or forking off, or moving more swiftly and kind of iterating the social constitution. So maybe I can end there.